Hi folks, I want to give you some extra help with the 1.6 homework because I'm getting questions about it, so I think we need to talk about it a little bit more. So 1.6 homework, and I'm going to look at numbers 12 to, I don't know, we'll see how many we need, maybe to number 26. And I'll do most of the evens in there because I want you to get practice doing the odds. And these are working with the properties of inverse functions mostly. So I'll really be showing you two ways. But let's kind of get some background first. We are going to be working with logarithms. And so our big rules of logarithms are natural log of a to the c is equal to c natural log a. And that means that if you have natural log of something with an exponent on it, raised to a power, an exponent is something raised to a power, it can instead, in this world of logarithms, change to go in front of the natural log, and now it's just something being multiplied. And they're equivalent. That's what the equal sign means. It means in this crazy world of logarithms, the value won't change if you do that. And that's with natural log or if you have log of any other base. We mostly work with natural logs. The next one is natural log of m times n. If you have the natural log of things being multiplied, this is multiplication here. It can be split into or expanded into separate terms, natural log m plus natural log n. So they each get their own logarithm, and I'll come back and look at that in a moment after we talk about a quotient. So natural log of things being divided, and that's going to be natural log of m minus natural log of n. So let's look back at both of these two rules, and if you have the natural log of stuff being multiplied or divided, then it can be expanded so that each factor in the numerator or denominator gets its own natural log term. So these rules could really be put into one rule that says if whatever the factors in the numerator, then when you give it its own natural log term, it'll be a positive term. If you have the natural log of something that the factors in the denominator, then when it gets its own natural log term, it'll be negative. So this one's in the numerator, the m is in the numerator, it'll be positive, the n is in the denominator, so it'll be negative. Here's an example. Natural log, that's ln, of ab over cd. So each of these factors, each of these four factors, two in the numerator and two in the denominator, will be their own natural log. So you're going to expand to have a natural log A, a natural log B, a natural log C, and a natural log D. The sign of the term is dictated by where the factor began. If it began in the numerator, then the term will be a positive term. And if it began in the denominator, then the term will be a negative term. So we have positive for the A and the B that began in the numerator, and minus for the C and the D that began in the denominator. So now we'll use some of that. It's a good review for the problems coming up. Number 12. We have 4 to the x equals 64. So this is very similar to number 11 that you need to do for your homework. And there's a couple different ways of doing that. You could rewrite this, and this is not the best way, I'll warn you right now. We could say 4 to the x equals 4 cubed because 64 is the same as 4 cubed. And then you have the same base formula that says we know there's a statement of equality. If the bases are the same and these two things are equal, then the only way for that to happen is that the exponents must be the same. And that would mean that x is equal to 3, and that is the answer, and that's great, but it won't work every time. So I really rather do something that may take longer but works every time. So now, all right, or 4 to the x equals 64. And you can do whatever the heck you want to an equation as long as you do the same thing to both sides of the equation. I have an exponential function, so I'm going to use logarithms to undo it. My problem is, let's look at this a little closer. The x that I need to solve for is trapped as an exponent. And when I'm done, I want to have x equal something, and I don't want that x to be an exponent, so I want to take care of that by taking advantage of inverse operations. So natural log is being applied to both sides. I'm taking whatever was on the left side and natural logging it, and whatever's on the right side and applying natural log to it as well. And now I get to free that x from being an exponent because our first rule of logarithms that we had up here, that's what we're going to be using a lot here. We're going to bring the exponent forward, and amazingly but truly it becomes a factor. So x times natural log of 4 is equal to natural log of 64. Trying to get x by itself because this is an equation, and what we do with equations is we solve them. So I'll divide by natural log 4 on both sides. That's just a number that you put into your calculator. And x is equal to, well, I don't know, I'll put in my calculator. So we have natural log 64 divided by natural log of 4. 3. X is equal to 3. Same answer as before, extra steps, but that's okay because it's a surefire way to get there. So let's go on to number 14. 5 raised to the x plus 1 is equal to 125. And you can do the same thing as you did over here. You can have both of the bases be 5, and that will work, but it won't work every time. So instead, I'm going to apply ln. And I want ln on the left, but I've got to do the same thing to both sides. Natural log of 5 to the x plus 1 equals natural log of 125. Now, my exponent, there's no rule that says it has to be just plain old x or that it even has to be plain old one term. You're going to use rules of logs. Natural log a to the c equals c natural log a. That means that when you have logarithms, if something is raised to a power, the log of something raised to a power, the power can come forward and become something you're multiplying by instead. So x plus 1 natural log 5 equals natural log of 125. And now solve for x. We'll divide by natural log of 5 on both sides. And I get x plus 1 equals whatever number this is. Natural log 125 over natural log 5 has no variables in it, so it's just a number. And then subtract 1 from both sides. And that's some number that I'm going to get on my calculator. Sorry, you can't see this very well, but that's better. All right, so we have natural log of 125 divided by natural log of 5. Enter. And I can put minus 1 now, and it'll carry along my answer, and that's 2. X is equal to 2. Okay, let's do a couple more of these. Maybe just one more. Here's number 18. And then I'll go on to the other type. 1/5 to the 2x plus 1 equals 25. Same thing, I need to solve an equation. And so I need to get x by itself, but it's locked up as an exponent. So we'll use logarithms, apply ln. We'll use logarithms to free that because rules of logarithms let us do that. Natural log of 1/5 to the 2x plus 1 power equals natural log of 25. Natural log of 25 is just a number. Use your rule, natural log a to the c equals c natural log a. You don't have to memorize the rule itself, you have to memorize how and when you can use it. So this exponent is coming forward as a factor. 2x plus 1 in parentheses times the natural log of 1/5 equals natural log of 25. Solve for x. And so I'm going to divide by natural log of 1/5. And we get 2x plus 1 equals natural log of 25 over natural log of 1/5. Moving up. And then we'll subtract 1 from both sides. And that gives me 2x equals natural log 25 over natural log of 1/5 minus 1. And finally, I'll divide by 2. And dividing by 2 is the same thing as multiplying by 1/2, so do whichever you want, but I'm going to multiply by 1/2 just to make sure you see that. Minus 1 times 1/2 or divided by 2, same thing. Negative 1/2. All right, let's move on to number 24. We have e to the x equals 1, and so we're going to apply ln, and this is where it's a direct inverse, e and ln. Oops, this should say apply ln. So we have natural log of e to the x equals natural log of 1. And these are inverse operations, so we just get x. It's a composite of a function with its reciprocal. No, I'm so sorry, it's not reciprocal. It's a composite of a function with its inverse. Natural log of 1 you can put into your calculator, that's 0. So x is 0. And go back and verify that. E to the 0 is 1. Any numeric value raised to the 0 is 1. Here's 26. E to the 3x plus 1 equals e to the 7. Moving up. Apply ln. Natural log of e to the 3x plus 1 equals natural log of e to the 7. These are inverse operations, so what you get is just 3x plus 1 equals 7. Natural log and e undo each other, so you just get those and they fall down, they're no longer exponents. And solve this. We'll subtract 1 and divide by 3, and x is equal to 2. Okay, so hopefully this helps. Certainly ask questions if you have them, but I'm hoping that this will clear up a lot. I don't want you frustrated. Have a good day.